In this video clip, we are going to take a quick look at how to draw structures given a name. We've already looked at how to name a structure when it's given based on how many carbons are there and whether or not there's a single bond, a double bond is present, or a triple bond is present. So we looked at naming alkanes, alkenes, and alkynes. Now what we're going to look at is how to actually draw them from the name. If you're given the name, how would we draw it? And so we're gonna give that a go. So let's take a look at our first example. We've got 3-octene. So I like to use a lot of different colors when I'm doing this to identify a few different things. The first thing I'm going to notice is that there's ene, which means that there's a double bond, right? So this is going to tell me double bond. So that's important, my double bond, and that the number that I see out in front goes with that double bond, right? That's important to me. The other piece that I can see in here is the oct part. Oct is telling me then that there's 8 carbons, right? If we go back to our chart, which is right up here, oct means 8. So we got to have 8 carbons in our chain, and at carbon 3 should be our double bond. So when I go to do my structure then, I like to start with just my carbons. So on carbon 3 is where I'm going to see my double bond, and then I'm putting in the rest of my carbons. 5, 6, 7, 8. So there's my 8 carbons. At carbon 3 is my double bond. And then I know that the remaining bonds to carbon, remember carbon's going to make 4 bonds, every carbon is, the remaining bonds have to be to hydrogen because there's nothing else indicated as part of this hydrocarbon. We know that the rest of it just has to be hydrogens. So my first carbon's getting 3 hydrogens. That'll get 4 bonds around it. If I look at my second carbon, it's already got 2 bonds around it. So I know we just need 2 hydrogens there, and that fills the bonding capacity of that carbon. And then my next one, I only need 1 hydrogen because it already had 3 bonds. Same with my fourth carbon. And then you'll see that these remaining ones in the chain will each only need 2. So I'll put them in. And last carbon is going to need 3. And so that's how we do that expanded drawings that we've talked about previously in the course. But some of you might say, oh man, that takes way too long. I don't want to draw all that stuff. Can I do it a shorter way? So there is the condensed way, which takes the hydrocarbon and puts it like this. So we just condense down all the hydrogens. It definitely makes it faster to draw. And if I check 1, 2, 3, 4, 5, 6, 7, 8 carbons, that's the oct. My double bond starts on carbon 3. All my hydrogens are there to account for all the other bonds that it needs to make for the carbons. And there's my structure, right? So you could use that expanded drawing. You could use, if you feel comfortable, you're like, I totally get this. I don't need it. I want something faster, then use the condensed drawing. All right, let's take a look at the next example here. We've got pentane. So again, break it down. We've got ane. That tells me that it's single bonds between carbons. And the pent part tells me that we've got 5 carbons, right? So I'm going to have 5 carbons in my chain. So there's my 5 carbons. They're all single bonded. And then I know that the remaining bonds for each carbon, so that each carbon ends up with 4 bonds around it, has to be to hydrogen. So this would be my structure for my pentane. If we were doing a condensed diagram, I usually start it by doing this. I'll put my carbons. Some tend to give a bit more space when I'm doing it. And then I'll do 3 hydrogens because I know that carbon's already made 1 bond. This one needs 2 hydrogens. This carbon needs 2 hydrogens, 2 hydrogens, and then 3 hydrogens. You'll notice that on this example, I put these 3 hydrogens on the first carbon on the left side. That's okay. You can have them on the left side or the right side. You'll see them done either way. A lot of the time, though, you'll see that very first carbon, they'll put the hydrogens on the left side of it just to show the carbon-to-carbon bond. And then typically the remaining ones will be shown on the right side of the carbons. But either way, it doesn't matter. So we've got our expanded diagram and then our condensed diagram there for our pentane. Let's try another example here. We've got ethyne. So our ethyne, if we're looking at ethyne, we've got ine tells me triple bond. And eth, if you remember back to our root names, eth means 2 carbons. So I've got 2 carbons and there's a triple bond between them. So each carbon's already got 3 bonds, so they're only going to make 1 more bond to hydrogens. There's my structure. That expanded one didn't take very long to draw. If you wanted to draw it without it being expanded, you'd probably just see it drawn like this. So that would be the condensed diagram. Right, so again, identify. I like to identify the root part of the name and what whether we've got that double bond or triple bond present. So let's look at this one, 2-heptene. So we know hept is telling us 7 carbons. And then ene is telling us a double bond. And remember, the number is telling us where that double bond is located, right? So on my structure at carbon 2, so I know single bond to the first and second carbon, and then at carbon 2, that's where I'm introducing my double bond. And then I'm going to draw the rest of my carbons in. There's my 7 carbons. And now we just have to put in our hydrogens. So the first carbon is going to get 3 hydrogens. Second carbon's already got 3 bonds, so it just needs 1 hydrogen. Same with the third carbon. And then these ones, carbons 4, 5, and 6, you'll notice they all have 2 bonds already. So they're going to get 2 hydrogens. And my last carbon only had 1 bond to it, so it's going to need 3 hydrogens around it. So there's my structure for 2-heptene. Again, if I did this condensed, I'd probably start with just my carbons. Again, give some space between your carbons so that you've got the space to draw the hydrogens in. And there's my 7 carbons. So I'm going to have H3 there, CH, CH, 2 hydrogens, 2 hydrogens, 2 hydrogens, 3 hydrogens. So there's my condensed diagram. Remember, the number of hydrogens you have connected to a carbon is to fill carbon's bonding capacity, right? Carbon wants to make 4 bonds. So if we've drawn it and the carbon to carbon has 3 bonds like this third carbon did, since we had 3 carbon to carbon bonds, we only needed 1 hydrogen, right? So just remember where those hydrogens are coming from when you're drawing these things. Good luck with your drawing.